Okay, so welcome to this webinar today now on testing the 150% model in embedded software projects. It's with myself, James Voller, and we also have Ingo Nichols from one of our partners at Vectorcast on the line who will be presenting a little bit later. Myself, a pre-sales solutions consultant for Siemens PLM, and I do have a vast background in support, training and consulting with various businesses worldwide. Okay, so Polarion ALM was founded in 2004 with the vision to disrupt the industry. Polarion ALM actually launched a year later with the industry's first unified 100% browser-based ALM solution based on one repository, data structure, and business logic. But of course, we have not stood still in this time, and in the last 12 years, our customers have been able to unlock unprecedented synergies and empower their disparate teams. Their feedback has obviously helped us to further deliver and expand and refine the power of the Polarion product. Polarion was actually acquired by Siemens in 2016, and this has obviously helped us bring out a wider company footprint and support our enterprise customers worldwide, which has propelled us into the next growth phase. The best way to articulate the value we can provide is through the hundreds of global 1,000 companies and the over 2.5 million users we already have relying on the Polarion product every day. Our customers rely on the flexibility of the ALM solution to empower and connect all internal and external stakeholders in complex development ecosystems with the level of information and functionality they need to collaborate, stay in sync and succeed. Here you can see the full set of capabilities unified within the Polarion platform to comprehensively address the development lifecycle. A great aspect of the architecture of the solution is that organizations can actually set out to solve a specific pain point and then later evolve and pursue incremental deployments as needed. By utilizing Polarion ALM, it allows you to deal with complex software development, which is becoming increasingly fast-paced. The quality of software produced will also be of higher quality through early detection of defects. Polarion does ensure that organizations can facilitate software maintenance. Software engineering orchestration is managed through end-to-end traceability and ensuring security within the application via our user role management. And Polarion also allows PLM to ALM integration to fully manage software and hardware requirements with testing included there as well. Okay, let's look at some of the challenges that are being faced within our variance model. So ever since programming began, in most development projects, there's existed ever-present needs to reduce cost, minimize effort, and shorten the time to market for releases and products. At the same time, the underlying and enabling technologies are rapidly evolving, while simultaneously the range of possible target platforms are widening. And as always, end-user customers are requesting more products, while their requests are frequently made for more deliverables that are tailored to each individual's needs. However, at the same time, customers are requesting more products, and their requests are more frequently tailored to their particular needs. And the experience of many organizations shows us that the traditional manners of development, focusing on activities, primarily the delivery of single projects, is proving to be insufficient in meeting these challenges, irrespective of whichever methodologies are actually utilized. So what are the solutions of these challenges that are being faced? The customary approach followed by software developers, and generally an approach used by engineers in most and all domains, is to expedite productivity by basing new deliverables upon work that has been done previously. And this is a cloning approach. As we can see here, this is a traditional cloning process diagram. So we start off with a master, we copy and cut and paste to produce a clone, and then we can modify this as needed, and this is traditionally what a variant is. Software development has significantly evolved over a relatively short period of time, enabled by a large measure and acceptance of lifecycle management approaches using standardized artifacts, infrastructures, and workflows. In deploying Polarion's unifying suite of application lifecycle management capabilities, customers experience profound benefits to productivity, efficiency, quality, spanning through all phases, from the elicitation phases through requirements, through testing and validation, and ultimately the release, while preserving comprehensive traceability, enabling collaborative agility, and effectively managing change. For standardized infrastructure, we can copy our master document and modify as needed for each variant. Using Polarion, we can then push changes from our master to our different variants. Polarian's branching functionality allows users to have master documents which are branched to reference work items such as requirements, but then allow users to create new work items in the document for each product variant. Another tactical approach routinely exploited is to identify commonality among branches, thereby isolating these as core assets that can be managed singularly, yet reused in multiple branches. As volume of concurrent cloned items increases, so does the management complexity. The maintenance of these clones can become very, very time-consuming. There are limitations of minimalistic approaches, such as the benefits of core reusability may not extend to all shared elements. It neglects greater reusability opportunities. And the nature of shared elements overlap between several projects and products. Research has actually shown that even some parts of past projects are reused in an ad hoc manner, for example, by adopting a cloning strategy of copying and modifying existing projects. Ultimately, when the volume of activity, particularly concurrent activity, is increased, then the effort to manage, maintain, evolve the concurrent versions and releases typically becomes an impediment to further gains in the volume of output that you can actually do. Further, the percentage of resource utilization for management and maintenance increases to the point where more time is actually being spent maintaining than developing. The solution to these challenges is Polarian variants. The variance is licensed separately as an add-on to the Polarian product, which significantly augments the core ALM solution. Variance is based upon proven product line engineering principles and practices, the fundamental concept of which are the foundation that make it possible for manufacturing processes to effectively support widespread variations. Polarian variance is firmly rooted in these concepts, distilling the benefits of product line engineering approaches into tangible capabilities that are readily exploited to augment and accelerate ALM capacity in order to successfully manage software variation. The logical progression is ALM evolution. Product line engineering is the process of engineering products in a product line, taking advantage of commonality, having a clear understanding about the variability, and strategically planning the software reuse. Variability is a product line characteristic that may differ among different members, so functionality, quality attributes, environments, and constraints, and so on. Variability management is a central component of every product line engineering approach. It allows managing common and varying parts as well as their interdependencies, and it allows configuring, building, managing product line members. In the more balanced approach, the common aspects as well as shared parts are supported in the core asset. Variation points for application-specific extensions are identified as well. In the so-called maximalistic, aka the 150% approach, core asset supports all necessary adaptations to derive all variants automatically. The choice of which approach to follow is strongly influenced by the type of activities, for example, project-orientated versus product-orientated business, and especially driven by ability to predict the levels of variability that are going to be occurring in the work streams. So let's start looking at how Polarian actually deals with this then. So here we have a screenshot of how the feature model can appear within Polarian. Each feature is an individual work item with its own process and with its own attributes associated to it. Using Polarian live documents, users can build out master specification documents that will contain common shared requirements and additional specific requirements in there as well. The variants add-on also allows users to set a property of work items in a master specification that sets certain restrictions or limits the item's inclusion in variants. The product variant in Polarian is a selection of features that are saved to a variant work item type. These features that are selected can be based on mandatory ones, optional ones, alternative features, meaning that the only one or the other one can be selected in that feature group, such as a headlight being a halogen or a xenon. It obviously can't be both. It's one car part, you're going to have a choice of either or. The Polarian variants add-on also provides users with a matrix view of what features are selected for each variant, so it's very, very quick and easy to be able to see what's included, what's not. And we can see this from this screenshot here that we have this matrix available with the green ticks, red crosses to very quickly highlight what is being used. Product variant documents can also be generated quickly from the variant work items within Polarian. An example of this is actually shown here. So working with our work items, we can actually generate documentation from those specific work items, and I'll be showing you this within our live demo. So let's actually look at Polarion in action now. So Polarion is a web-based application, so once it's installed on your server, all of the users will actually be able to browse to Polarion using Chrome, Firefox, Internet Explorer, and so on. Once you've logged in, you'll then be presented with an interface similar to this. On the left-hand side, we have our navigational pane. So within here, we can actually search through our project that we're working in. In this case, we're working in our weather station project, and we have a home page available to it. We can also see some specific variants add-on features here. So we can see our feature model. We can see this as a document that's shown within Polarion. We also have our master specifications. So again, we can click on these, view an overview of the process, and then see our system requirement specifications. Because Polarion variants is actually built on Polarion ALM tool, we also have our communal functions such as our work items. So we do have our work items view, and every single work item is viewable in this database style view that we have. Within here, we can search through our specific requirements that we may have. We can click on these, see the details of these work items with their attributes that are stored. So we can see here what types, what severities we have, what requirement type they actually are, the original author, any users that they may be assigned to, and also the status of the work item. Every single work item has its own workflow and process that it needs to adhere to. We can see all of our different work item types through here, and we can see our features and variants that are listed here as well. Polarion also uses documents and pages, and these are our live documents which store our specifications in this case that we'll be able to see. So we can see our specification documents, and we also have the live pages for the reporting. An example of this is shown here, so we can actually see our requirements test coverage. So this is a standard sort of reporting page within Polarion. I'm now going to guide you through the process of actually creating a new variant within the Polarion variants add-on. We can do this by clicking on our variant here to filter down, and we can actually then create a new variant within here. So we can see our existing ones of our weather station trend line, our weather sensor pro, and our weather sensor basic, but I want to create a new variant of this. I can give it a name. I'm going to give it a name of Smart Weather Sensor Plus. We can add in any descriptions if we wish, using our rich text editor that is available here as well. And I can create this variant. We can now go through our feature selection process. So we've created the variant. This is essentially just a work item type within Polarion, but it's built upon this feature selection. So I can now view the features that we want to include for this variant. We can see here as going through the selection process that we've actually got a couple of errors here as it's going through the validation of our variant so far. We can view these errors. We can see that actually we've got the different alternatives, so we need to select one or the other. Is it indoors or outdoors? And we also need to select, is it wired or wireless? So it guides us through this process to ensure that every variant is fully managed. So I'm going to select here. Okay, so whilst going through creating our new variant, we can see that we have these errors within here. We can actually then set whether it is indoors or outdoors. So this is what I'm doing here in this part of the process. So we can see our errors that are listed. And we can also then set whether it's wired or wireless. We can also select our various different features that we may have that we want to include. So some of them are optional, some of them are mandatory. We can see these listed within here. So we have a mandatory feature that we need to include. We can include this. We also then have our optional features as well that we can start to include. So we can go through the whole list of different features that we actually have and start to build out our variant from this. Once I've made these selections, I can then save my variant, and we now have our variant Smart Weather Plus created within the Polarion application with the 4 features that are included. Once we've actually selected our features within our Polarion variant, we can actually then automatically generate documents for this. And this is the next part of the process that you'd want to go through. We can do this by generating documents here, and we can select what documents we actually want to create and what we want to derive them from and where we want to put them. So I'm going to select our master specifications, and we're going to have a system requirement specification and also then a test specification that's going to be generated for this variant as well. So I've selected what I want to use to branch these documents from, and we can now set our target spaces for these. So I'm going to put them into our variant space that we have for our Smart Weather Sensor Plus. I'm now going to generate these documents, and a job is now running to actually create these documents. Within our documents and pages now, these jobs should have run, and within our variants folder, we'll actually now be able to see our system requirements specification for our plus that has been selected here, so we can actually see that our document has been generated. We can see what features and user requirements have actually been selected as a result of the process I've gone through. And we can actually see that it has been branched from our Smart Weather Sensor Basic branch, but it's added in the additional specifications to the features that I've included as well. We also then have our test specification, which has also been created. Okay, so that was a very, very quick whistle-stop tour of the Polarion variants functionality. I will now be able to hand you over to Ingo, who will be able to guide you through the rest of the presentation.
Yes, short introduction to me, myself, and Vector Software. My name is Ingo Niklas. I am Field Application Engineer at Vector Software. And who are we? Vector Software was founded in the 1990s in the United States by two engineers. They were doing software test, embedded unit test in a certified environment for the 0178 in the highest class of criticality. And they did this manually, and it was a lot of work, a lot of boring work. So they were looking for tools to automate this process of automated unit testing, and they couldn't find any tools, so they wrote their own tool. And they successfully used this tool, which was VectorCast, to certify the application and to do the embedded unit test for the 0178. And so VectorCast is now our product. Vector Software is founded in the United States, but we have in the meantime a lot of sites in different parts of the world. The European headquarters in London, and we also have an office in Germany. That's where I'm sitting in the sunny city of Kempen. And we are, since the beginning of 2017, we are part of Vector Informatik. So obviously, good companies get acquired by other companies, and Vector Software was acquired by Vector Informatik. By pure chance, we have more or less the same name and even a similar logo, as you can see on the bottom right. So now we belong together, obviously. Where does VectorCast fit in your environment? So VectorCast in general is meant to help you in the testing process, testing your application when it comes to unit testing, integration testing, and or system testing, measure code coverage, and build test environments. We do know that testing is not everything in the world, so we try to integrate into your existing environment. We have integrations, for example, to requirements management systems or application lifecycle management systems, like, for example, Polarion. We do also integrate into model-based development tools, like, for example, MATLAB Simulink. We have integration to static code analyze tools. And then, of course, when it comes to testing, it becomes relevant. What is the compiler that you're using? What is the target that you're using? So we have integrations, or we work together with almost every or any embedded compiler that is used in the market. When it comes to the test process, then we see that there is a step-by-step improvement, and some companies are just beginning with a proper process. Others, mostly those who have to certify, already have a good process in place. But looking at the process, you can do something like static code analyze. You can measure code coverage. Of course, it's always good to do requirements-based testing. That's why we have a good relationship to Polarion. It's good to not only test once, but to do regression testing, to test again and again, retest the code that you changed, continuously testing. And then when it comes to optimizations, especially when we talk about testing in different variants, when you have to exercise or to execute the same test case in 100 variants, then it's interesting how we can optimize the testing process. And one of the possible ways of saving time is, for example, doing something like change-based testing. This is something that I will quickly talk about. And of course, we can parallelize the testing, for example, with Jenkins or with other continuous integration server tools. So let's have a look at the specific topic that we want to talk about, the 150% model. So James already showed us the weather station, and the weather station example has had three variants: the basic, the trendline, and the pro variant. While James mostly focused on the application lifecycle management, on the, let's say, the design and the requirements management, I want to focus on the software. What effect does it have on the software? If we have 150% software that tries to fulfill the needs of each of these variants in one software package. And what does it mean? Well, we may have some parts of the software that are identical in all variants, but it may also be that we have some specific files that are only relevant for one variant of the software. In other industries or in other projects, we may have other variants. For example, we can different variants on our application that we build when it comes to compile options. For example, compile defines for the preprocessor. You can enable or disable source code using compile defines, for example, to exclude or include feature into your tool. We can have the same software that runs on different boards. So of course, you could say I tested my software on one board and it works, so I don't need to test on other boards. But to be sure that the software really works on every board, you should definitely test it on each board. So in certified environments, when it comes to certification, especially in avionic or in automotive, you wouldn't want to deliver untested software on that specific board. So the problem is we have to test the source code multiple times in different variants. Maybe different included or excluded features, included or excluded source code, or board-specific things. What that looks like if we add or activate or deactivate code is using preprocessor directives. For example, we have on the left side the so-called 150% source code, which is even more than 150%, and it's switched in the software, or there is a switch, an if-def, using a preprocessor directive to decide, is this the basic device or the trendline device, or is it the pro device? And the preprocessor part of the compiler does disable or enable the specific line or select the specific line that is relevant for this variant. And then this results in the end in different implementations of the same function. So obviously, when it comes to testing, this specific part will probably need specific or variant test cases, not the same test case in all variants. So looking at testing of such a project, of different test environments in a project, then in general, let's say we have the source code on the left side, just a couple of files, then usually, or the recommended test process would be to have one unit test environment per file. That means we have a couple of test environments. So the top part of this graph, we have individual test environments per C file. Each of those test environments has its own results, passing or failing test cases, and code coverage results. And each of these test environments has a couple of test cases. The same applies to integration level testing, when we test more than one file, than one file, when we test the interworking of, let's say, a component of the project, multiple files interworking with each other. Again, we have a set of test case data. We have a test environment that is separate from the others, and we have results and we have code coverage. And then finally, even in system level testing, when we test the whole application, then we can test on the simulator, which is a different test environment than testing software in the loop or hardware in the loop or processor in the loop or testing on the real hardware. So different test environments. Now, while this may look complicated, it becomes even worse when we talk about variants. So in our example with the weather station, we have the same test environment 3 times, and this could even be 100 times. So it's a problem how to maintain, how to manage the test data and the test results. And how can we optimize the test setup? Well, the first thing that we can do is we can isolate the generic test case data, those test cases that are identical to all variants. We only need to maintain them once. The advantage is if you as a user want to change test case data, you only need to do it once and you don't have to bother about the other variants. But as we have seen with a preprocessor directive, it can be that some test cases need to be specific to one variant. So some of our test cases may still have to live inside the variant. We have to be aware that some test case data is generic and identical for everything, and others are specific to one variant. So now when we do a source code change, for example, which test case needs to be re-executed? And that's the question that has to do with change-based testing. What do we have to do when we change source code? For example, here we changed one file, and this one file, of course, means that we don't have to do everything. We just need to rebuild one unit test environment, but in every variant. And maybe even not all test cases are affected by that source code change. So there should be a way of intelligently selecting test cases and environments that need to be rebuilt or to be re-executed. And what this can look like, I would want to show in a quick live demo. So let's open VectorCast. And this is an overview of our test environments in our weather station project. What we can see is that we have the 3 different variants. We have the basic variant, the trendline variant, and the pro variant. And for each of these variants, we have unit test environments, integration test environments, and system test environments. So when we open the unit test environment, we could have different subcomponents, and then for each subcomponent, for each C file, individual unit test environments. So this, of course, needs to be duplicated or multiplied with the number of variants. So we have the same thing under the trend line, and we have the same thing under the pro. When we do an incremental rebuild, so when we rerun all necessary test cases, then this should be quickly. So when I really build everything, then it takes more than 45 minutes, which we don't want to do now. But we can see that if we don't change any source code, if we don't change any test case, then we don't need to rebuild anything. We can see that we can maintain the results in the individual variants. And for each individual test environment, there are unaffected test cases that did not need to be re-executed. And we have no test cases that needed to be executed. So more than 2,000 test cases could be maintained. So when I open one of the unit test environments, for example, in the basic variant, then this, of course, needs to be maintained by the tool. Where is the real result of the execution? Where's the result of the code coverage stored? So here we have our display size function. And another example is the Z0 function. When we have a look at the Z0 source code, we see that this is not variant, so we can have identical test cases in all variants, whereas the display size function has this preprocessor directives. So we have to have different test cases in different variants. And that's where this specialized hook is for. We can say in this unit test environment that we opened, this specific unit test case is specialized to this variant, so that the results or the expected values of this test case are specific to this variant, whereas other test cases may be identical in all variants. So this one is not specialized. That means it's executed in all test cases, or in all variants. What we can also show is the interworking that we can do with Polarion. We have a requirements gateway where we can interact or get data from the Polarion tool. We can import requirements, and then it's relevant for the variants that we can, for example, filter for the requirements that are specified in specific documents. You could also use other filters to just get the requirements that are relevant for this specific variant. Once they are imported, we get a list of requirements. We see the ID, we see a title, and we also see a description. So these requirements can then be linked with the test case. For example, we can link individual requirements that are imported in the project to the test case. And of course, this data can also be exported in the end. So let's do one source code change or one test case change. Let's change this test case data, the benefit of change-based testing when we close this environment. So this was a generic test case, a test case that is identical to all variants. We just changed one input value. And now when we do the incremental rebuild or the change-based test, then we will see that we need to rerun this one test case that we changed in all three variants that we have for the weather station. And we should see that this is pretty quick because we don't need to rebuild anything. And we really only have to rerun this one individual test case. So we see nothing needed to be rebuilt, and we see that we ran one test case in the Pro variant on this environment, one test case in the trend line, and one in the basic variant. But now when we change source code, for example, we can change the return value in the basic variant. Maybe we don't like the number 13, so we return the number 12. Then this, of course, means that we have to rebuild the unit test environments because we changed the source code. So when we now do the incremental rebuild, we will see that we have to recompile and to relink, of course. And let's see what Vectorcast tells us, which test cases needed to be re-executed. Since this one source code change only affected one variant, we probably only have to rerun one test case. And the one test case is here in the variant basic, which is the only variant that is affected by the source code change. The other environments needed to be rebuilt because the source code changed, so it could have affected the resulting, the pre-processed file, but in this case it didn't, so we didn't need to rerun any test cases. So together with change-based testing and then parallelization, so we can parallelize the execution of these unit test environments. This makes the source code testable even in hundreds of variants. So the last thing I want to show is the dashboard. So what does it look like when we want to get an overview over the results of our testing efforts, when we want to see what's the status of our project? Then we have this server-based dashboard that can show us the kind of testing activities and other metrics on the project. This is hierarchically. It's orienting on the structure on the source code, so we can navigate into our source code, and we see in this case we have 3 different directories, which could be 3 different subcomponents. We can have, for example, a look at one of those subcomponents, or go one level up and look at another subcomponent. What we see here is then specific data for this one subcomponent or even for one file, static code analyze issues, metrics, and testing data. And what we also see is the code coverage that we achieved in color. So green means good code coverage, red means bad code coverage. And on the left side, we see the bigger the block, the more code. So we see the code coverage versus the code size. And on the right side, we see the same thing, but the code coverage related to the complexity. So the bigger the block, the more complex is the code. And the nice thing about this is we can see where are deficits, where should we put some additional testing efforts, are the functions or components that we tested, did we test the complex parts or the big parts of the software, or just the small parts or the easy parts of the software. And we can also focus on the problem zone or things where we didn't spend enough effort yet. And finally, we can also have a look at the source code, for example, at the source code of the display size function. And when we look at the source code, we see the original source code, including the preprocessor directives. And now when we look at the code coverage for this file, then we also see that we get the code coverage on the original source code. So we see that each of the variants of our source code has been covered in tests, in unit tests, in integration tests, or in system tests. And we could also include the results of the static code analyze and look at problems or issues that come from static code analyze. So this was my part of the show, showing vectorcast and how to test variants. So now let me see how I can make James the presenter again. Back to James with questions and answers, I guess.
Now for the Q&A session. So can you set up feature dependencies? Yes, Polarion can set up that certain features rely on other features, so i.e. must have, should have, and so on, optional. You can also set it up so that you can say if one feature somewhere is selected, it must not have another feature. And this is actually built on the Polarion linking model.
Yeah, I see a question here on the exchange of data to Polarion. What data can be exported? Well, what we the interworking with Polarion we showed already in multiple webinars. So maybe it would be the best to have a look at those webinars if you're specifically interested in what we can exchange or what the handshake between Polarion and Vectorcast can look like. But or just as a rough overview, when we imported the requirements, we link them to test cases, and then after the execution of the test cases, we can export the data back to Polarion. The data that we export is the test cases. That means we create additional work items in Polarion of type test case, and we also link the requirement to the test case. We add a test run where we store the result of the execution, and then in Polarion you can see the traceability between the requirement and the test case.
We've also got another question here of, we already have Polarion ALM. Can the variants add-on be installed on this? Yes, of course it can. It can be added to any existing installation of Polarion. It will work in harmony with it, so it won't affect any existing projects that you have. It's just an extra installation onto the server, so your users won't have to do anything at all to their environments. Obviously, it's browser-based, so they'll just be navigating to Polarion as normal. It's just an additional license that would need to be added on for it.
Yes, here's the question: what system and functional testing tools can be used with this system? I assume it's a question related to my part of the demo, and it's a difficult to answer question. What system and functional testing tools? My answer would be that Vectorcast relies on the compiler, so we have to understand the compiler, and other than that, we support your test environment. So we can script or use your IDE, your debugger, your testing tools that you have. We have a way of scripting the execution of test cases. We have Python scripts or batch files that can be used, or shell scripts on Linux that can be used to execute test cases. Not only unit test cases, even system level test cases. We did already a integration with Canoe, for example, and vtest from Vector Informatique before we were acquired. So we can work with those tools, for example. And I would say that if you're interested in any interworking of VectorCast with other tools, just send me an email directly or get in touch with vectorcast.com with a specific question on the system or the functional testing tool that you're interested in.
Okay. We also have another question here of, can I link the MATLAB Simulink models with the Polarion requirements? Yes, there is integration available through the Polarion extensions portal for this. This will also work with the Polarion variant add-on and with Polarion standard ALM product. So there's full integration available for that.
Okay, the question was how to say, do we integrate with Cucumber? To be honest, I don't know Cucumber. I have to double check. I have another question which is in German, whether or not VectorCast can work with mocks, or how do we mock? Yeah, well, VectorCast does an analyze of the source code, and we check whether there are functions that are called that are implemented outside of the code under test, and then if desired by the user, so you can choose to say you want to use the real code, or you can choose to let VectorCast create a stub or a mock or a fake or however you want to call that. So yes, VectorCast can automatically create mocks or stubs.
Got another question here of how can we ensure each variant is correctly tested? Okay, good question. So using Polarion's linking functions that we actually have, haven't shown any of that in the demonstration today. Users can actually ensure that every requirement that may be used in a variant has that full test coverage. So we do have different traceability tables available for this to provide easy views for the users, and other reporting methods that are available. So I did show a brief live report page. We can use those to actually show requirements without test cases as an example. So it's just using the Polarion linking functions that we have.
Yes, and let me answer the same question. Of course, it's relevant to look at the code coverage in the individual variants and to see whether you achieved 100% code coverage from unit level testing on each of the variant, which also provides you with an idea whether or not this variant was sufficiently tested or not tested.
It looks as though we've got another question coming as well of, can pure variants from pure systems be used to manage variants in Polarion? Very good question. That's one that we may have to take offline and start a discussion with offline. I'm not familiar with that one myself. So yeah, we can certainly take that discussion offline and work our way through that one.
Yes, I've got one more complex question here about the interworking or interaction with version control management and branches and test case data. Well, the test case data of VectorCast lives in, let's say, in ASCII files, and so they can easily be merged or used in source code management. And usually you would well, let's say, attach the test case data or store the test case data together with the source code so that they are in sync with each other. Because, of course, if you change source code, you should also adapt test case data. And so the branches and the variants would have their own test case data together with the source code. I hope that explanation was enough. So other than that, yeah, let's continue the discussion offline.
Okay. I've seen we have actually come to 11 o'clock now, which is the end of the webinar.
Great Britain time. It's lunchtime in Germany. Yeah.
Okay, so if you do have any other further questions, do feel free to put them through to us. You can also find out more at the Polarion Siemens website as well, which is up on the screen now. So please feel free to contact us through that. So thank you for attending today, and apologies for the issues at the start.
Yeah, thank you very much. Goodbye.